Section 4.3 is multiplying and dividing fractions, but they're just giant versions of simplifying. So when we multiply fractions, we multiply straight across the top and straight across the bottom. And you can reduce at the end, but I like to do it kind of like what we've been doing. Get them all in little prime factors and cancel from the beginning, and it'll make it easier, okay? So let's look at this first chunk. It says, if we want to multiply straight across, we can. So what's 3 times 5? 15. What's 7 times 11? 77. And then at this point, you can ask yourself, do 15 and 77 have anything in common? No, because if you go backwards, this 3 doesn't cancel out with anything on the bottom, and this 5 doesn't cancel out with anything on the bottom. So when you take the product, it won't simplify any further either. So that's your final answer, 15 over 77. The number 2 one is exactly the same way, guys. Notice this 1 doesn't cancel out with anything on the bottom, and this 1 doesn't cancel out with anything on the bottom. So we're just going to multiply straight across. What's 1 times 1? So that's your numerator. And then what's 3 times 9? 27. And that's your denominator. So 1 over 27 is your final answer for the product. Okay? So it's just straight across the top, straight across the bottom. What we want to start doing, though, is notice that they're going to start getting a little bit more complicated. So what I do, and you do not have to do it this way. If you know how to do it the simpler way, and I'll show you what I'm talking about, you can. But I start doing factor trees for each of them and throwing them all up on the numerator and all up on the denominator, okay? So what is 6 split up as? 2 and 3. Do you really need to do a factor tree from him? No, okay? But over here, write 2 times 3. Is that okay? And what is 7 split up as? 7. So we'll just put times 7. So do you guys agree that we have 6 times 7 up top? Okay? But by doing it this way, we're going to see things simplify a little bit easier. All right, 77. Again, do we really need to do a factor tree? No. Some of you probably know how it splits up. How does 77 split up? 7 and 11. So guess what I can put right here? 7 and 11. And then 8, guys, we saw it a handful of times in our last notes, but if you want to do a factor tree, feel free to do it. What's 2 times 4? 8, right? Sorry, I'm going backwards. And then what's 4 split up as? 2 and 2. So over here, what can we add? 3 2s. And so it's kind of hidden, but we have 6 times 7 and 77 times 8. Do you guys agree? But by splitting them up when they're small, we can cancel sooner than multiplying straight across and getting these big numbers that we have to simplify, all right? So can this 2 cancel out with anything on the bottom? Yeah, just one of those 2's, okay? So this 2 is going to cancel out with this 2. Can this 3 cancel out with anything on the bottom? Nope, so he's going to stay there. Can this 7 cancel out with something? That's 7 over there, right? So when it's all said and done, you multiply straight across. Well, what's the only thing left on top? 3. And then on the bottom, we have 11 times 2, which is 22, times 2, which is 44. So that reduces to 3 over 44. If we didn't do it this way, guys, we would do 6 times 7 and get 42 on top. And then we'd have to do 77 times 8, which I don't even know what that is. And then we'd have to reduce 42 over... Can somebody in their phone real quick do 77 times 8? It's like the only... What is it? 516. So who wants to simplify 42 over 516? You guys are already kind of seeing that on your yellow worksheet. It's not the most fun, is it? So if we can simplify the smaller numbers first and cancel out, then it makes it a little bit easier, okay? So let's do the same thing here. Again, we don't necessarily need to do a factor tree for 4, but what is 4 split up as? So I'm going to just put a 2 and 2 where that 4 is. Is that okay? And then times 3. What is 3 split up as? Just 3. So do you guys kind of see it? We're taking 4 times 3. All right? 27. I'm going to do a factor tree because he kind of starts splitting up quite a bit. So what's 27 split up as? 3 and 9. And then what's 9 split up as? 3 and 3. So for 27 down here, I'm going to do 3 3s. Is that all right? And then 8, use what you've already done, right? What did we notice 8 was right up here? 3 2s. So guess what I can put right down here? 3 2s. All right. So you guys kind of see it? We have 4 times 3 and 27 times 8. But now we can start simplifying factors. So this 2 can cancel one of those 2's. This 2 can cancel one of those 2's. And that 3 can cancel out one of those 3's. And I'm glad this came up because I know Callie asked me about this on number, I think it's at 20 on our worksheet. When everything cancels up on top, we have to show that there is a numerator. And what I have kind of been a bad teacher about is when we're canceling them, what's 2 over 2? 1. What's 3 over 3? 1. So this whole time we've been canceling, we could throw a bunch of 1's up there. But why? You're just kind of cluttering it up. But keep that in mind when everything disappears. What's technically your numerator?
1.
A 1. Okay? On the bottom, we have a little bit more left. We have 3 times 3, which is 9, times 2 is 18. 1/18. Does that look okay? All right, so let me kind of go back for 3 and 4. Anybody feel comfortable with fractions? If you feel comfortable and you see easier ways to do it, what do I mean? Some of you guys might see that this 6 and this 8 reduce because they both have a factor of 2. You know what I'm talking about? Some of you, if you can do that and you want to do that, you can. But sometimes you miss factors, so I just feel like my way is kind of like the no-fail way. Just break them down and cancel them out. For example, 4 and 8 here. Some of you guys know that 4 goes into 8 2 times, so this 4 can disappear and the 8 goes to a 2. You can play around with that if you want to, but I kind of like doing it my way where it's kind of practicing everything. All right, what do we have going on here, guys? It's just still the rules from chapter 2. What sign are we going to have when we take a positive times a negative? A negative. So guess what I'm typing in my math lab right now? A negative, so I don't even have to worry about it. Guess what I'm putting in front of my fraction? A negative, so I don't have to worry about it, okay? And then I'm going to just do what we've been doing. How does 1 break up? It's just a 1. How does 11 break up? It's just an 11. So no simplifying on top. Is that all right? How does the 2 break up? He's just a 2, so he's going to go down there. And then 28, feel free to throw a little factor tree off here to the side. What are any 2 numbers that multiply to be 28? 2 and 14. And then what's 14 split up as? 7 and 2. So what can we put over here for 28? 2 2's and a 7. Does that look okay? So do you guys kind of see it? We have our 1 times our 11 on top, and we have our 2 times our 28 on bottom. But when we do all that, what do you notice happens? It's still negative, so let's make sure our answer is negative. Nothing cancels out. So what does that mean? It means we'll just have to multiply the top to get our numerator, and we'll just have to multiply the bottom to get our denominator, all right? So what's 1 times 11? 11. And let's just go left to right, okay? What's 2 times 2? 4. What's 4 times 8? Oh, gosh. I'm giving you the answers today, guys. 2 times 2 is 4. 4 times 2 is 8. Sorry. And then my mind's just moving that quickly. And then what's 8 times 7? 56. And what we could have done is we could have multiplied that from the very beginning and got the same answer. But 2 times 28 to me is not as easy as 8 times 7. Like having it broken down and kind of seeing, it makes the math a little bit easier. And you're catching if it simplifies or not. Because you might get to this step, 11 over 56, and like try to see if it cancels or not. All right, let's think about the sign on this one. What's a negative times a negative? Positive. So we're not even going to worry about our sign. Let's focus on 4. How does 4 split up? 2 and 2, so I'm going to put 2 and 2 up there for a 4. And then how does 33 split up? 3 and 11. So I'll just put a 3 and 11 right there. Feel free to do factor trees off to the side at any point, though. All right. What about 11? He's just going to be 11. And then 16, guys, he gets to be a little beefy, okay? So 16 multiplies to be 4 and 4, right? But what happens to each of those? Those are 2 and 2. So 16 ends up being 2 to the 4th there. So do you guys see what I'm doing? So I'm just taking my first numerator 4 times my second numerator 33 times my first denominator 11 times 16, and then start reducing what you can. So each of these 2's up top will take out one of the 2's on the bottom. Nothing will cancel with the 3, but the 11's will cancel out. So guys, what do we end up getting? 3 3 over 4. And again, think about another way we could do this. We could do 4 times 33 and get 132 or whatever over whatever 11 times 16 is, and then try to reduce that. Do you see how it's just a giant version of what we just did? It's just a big version of it, okay? Then they try to scare you with 3, but guess what? It's no different. A times B times C is all of them, okay? So we're going to do all the numerators, all the denominators. We're not scared by this. So I'm just going to do one big fraction bar. 1 is 1. 3 is 3. And then how can we split up 25? 5 and 5. Do you guys see that? So I have all 3 numerators up there. 1, 3, and 25. Do you see them? Okay. I'm going to go through and do the same thing with my denominators. How does 6 split up? 2 and 3 or 3 and 2. It doesn't matter. How does 10 split up? 2 and 5. And 16 we just did on the bottom of the front page. It was 4 2s. So let's put 4 2s down there. Man, that's a lot. So we have 1, 3, and 25. We have 6, 10, and 16. But now we can just start canceling things. 1 kind of just hangs out, right? The 3 will knock out a 3. The 5 will knock out a 5. And that's it, right? So up top, what are we left with? 1 times 5, which is 5. And then a bunch of 2s. So let's just take it one at a time. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. And at this point, if you need to go off and kind of do your multiplication, you're like, I don't know what 16 times 2 is. Throw it over there, you know, if you need to. So that's going to be 12, carry at 32. And then we have one more 2. 32 times 2 gets us what, guys? 64. There it is, a nice reduced fraction. Guess what? Variables, same thing. If you have them to different powers, just spread them out, okay? Otherwise, just let them hang out. So on this one, 2 splits up as a 2, 3 splits up as a 3, y splits up as a y. And then we just have 3 times 2 on the bottom. Does that look okay? So my first numerator, my second numerator, my first denominator, my second. What do you notice about all the numbers? They're all the same, right? So they all simplify. So this 2 over 2 simplifies to a 1. This 3 over 3 simplifies to a 1. And what are we left with? The y. But where is he located? Up top. So you don't necessarily need to write y over 1 like that. Like when you say you're 18, you don't say I'm 18 over 1 years old, right? And so you just have a y when it's only on top. If it's left in the bottom, you need that 1 up top to say, hey, it's 1/3. All right. Again, don't let these variables scare you. To me, they're easier than numbers because we know how they split up, right? So how does this a to the third going to split up? You got it. A times itself 3 times, and then times b. Is that all right? And then on the bottom, how's b squared going to split up? B times b. And how does a squared going to split up? A times a. Okay? They're easier. We don't even have to think about what the factors are, right? So let's look at this. 1a up here will knock out 1a up down here. This will knock down him. B will knock down. So a over b, is that what we get?
Yes.
Woohoo! Say you had 2 b's left. We know that b times b is b squared, right? If we had to multiply them at the end. Are there any questions so far? You guys doing okay? So remember what follows multiplication are these exponents. And so in objective B, they're just making sure you feel good with exponents. But guys, it's just what we've been doing, okay? What is 3/4 to the third? It's 3/4 times 3/4 times 3/4. Right? It's just whatever's in the parentheses times itself 3 times. Anytime you have a fraction that does not simplify in the beginning, when you square and cube it, it won't simplify, okay? So do 3 and 4 have any common factors? No, because what's 4 just split up as? 2 and 2. So there's no reason why we need to split all these up, because we're just going to have a bunch of 2's on the bottom, but they don't cancel out with any of the 3's on top. So our answer is just going to be multiplying straight across the top to get our numerator. So we'll have 3 times 3, which is 9, times 3 is 27. You got it? And then 4 times 4 is 16, but what's 16 times 4? 64. And you can just throw it over here if you don't know, right? Okay, we don't have to get everything right off the top of our head. 5 times 6 is 24, carry your 2. 4 times 1 is 4, plus 2 is 6, 64. And if they didn't reduce here, they do not reduce here. So you're done. There's no simplifying. All right, let's spread this one out. What does negative 4/5 squared mean? Negative 4/5 times negative 4/5, right? That negative is in the parentheses, so it's part of the square. But what do we know about a negative times a negative? Positive. So we don't even need to worry about the sign. And 4 breaks up to a bunch of 2's, but do we care? No, because what's the only thing on the bottom? 5's. So we are just going to get 4 times 4 on top, 16, and 5 times 5 on the bottom, 25. And if they didn't reduce above, they don't reduce below, just make sure you have the right sign, because a negative times a negative gives you that positive, okay? So 16/25 there. All right, so then good job, guys. Let's see if we can do division. Okay, yeah, you can do division. All right, so just kind of a quick reminder. Long time ago, and I don't know what land, 4th or 5th grade, you learned how to do fractional math. And division was just multiplying by the reciprocal. The reciprocal just meant the flip. All right? So every division problem, just look how they have it. The first fraction stays the same. So A over B stays A over B. But then our division changes to multiplication, and you flip the second one. So D was on the bottom, but now it's at the top. And you change it to a multiplication problem, which we just did the first 2 pages, okay? So you just have one step in the beginning to change it to multiplication, and then everything else is the same. So let's rewrite this as a multiplication problem first. The first fraction stays the same, 8 over 7. The division changes to the multiplication, and what's the second fraction change to? You got it, okay? At that point, guys, I'm doing exactly what I did on the front page. I'm going to break 8 down and 9 down and so forth, okay? What was 8? Does anybody have that memorized at this point? 3 2's, right? So we have 2 times 2 times 2. And then what is 9 split up as? Yep, so 3 times 3. Do you guys see it? So 8, if you need to do a factor tree, is 2 times 4, but the 4 splits up into 2 more 2's. So 8 is just 3 2's, and then 9 is 3 times 3. On the bottom, we have 2 prime numbers, which is nice, just 7 times 2. All right, are there any questions? So then just reduce what you can. What is it, just a 2? Not a whole lot of help there, right? Okay, so we have 2 times 2, which is 4. 4 times 3 is 12. And then what's 12 times 3? 36. And again, guys, if you need to go off to the side and do 12 times 3, feel free. So we get 36 there over what's the only thing that remains on the bottom? The 7. So 36 sevenths. You guys just did division. Okay. Let's rewrite this as a division problem. The first fraction stays the same, 4 over 9. The division symbol changes to a multiplication, and 1 over 2 is going to change to what? 2 over 1. If that was a 2, it starts as a 2 over 1, and it would flip to a 1 over 2, okay? So at this point, guys, I'm going to just do what we did on the front page. I'm just going to split each of them up. How does 4 split up? 2 and 2. And how does a 2 split up? Just a 2. And then on the bottom, how does 9 split up? 3 and 3. And how does 1 split up? 1. You do this, and sometimes it seems like you do it in vain because nothing ends up reducing. But the second you don't do it, it reduces. You know, so I always like to do it to check. Nothing reduces, does it? So what we're going to do is just multiply straight across the top and get 2 times 2 is 4. 4 times 2 is 8. So make sure you have 8 up there. And then 3 times 3 is 9. So 8 over 9. All right? So then they're going to throw in signs, but that's okay. We know the rules. The signs of division are exactly the same as multiplication. What's a negative divided by a positive? A negative, right? So we're going to keep this first one the same, negative 10/4, always, right? Division changes to a multiplication, and what's the second guy going to change to? 9 over 2. So this is going to be negative whatever, right? We know a negative times a positive is negative, so the negative is just going to hang out. What's 10 break down to? 5 and 2. What's 9 break down to? 3 and 3. What's 4 break down to? 2 and 2. And what's the 2 break down to? 2. Does everybody see what I'm doing? So I'm just taking each numerator and putting them together up top, breaking them down as they do it, okay? At this point, what's the only thing that cancels? One set of 2's. So we know our answer is negative, and then it's going to be 5 times 3 is 15, but what's 15 times 3? Throw it over here. 3 times 5 is 15, carry your 1. 45, okay, so we have negative 45 over 2 times 2, or 4. Negative 45 over 4. That's a really big negative sign. Wow. You're not gonna miss that negative on there, are you? Is that okay? All right, so this is what I was kind of talking about. This next one, guys, is 3y over 4 divided by 5y cubed. If you have like a number that is not a fraction, it's always over 1, okay? Like you're 21 over 1 years old, technically, all right? So that way, when you go to flip, you know what it flips to, all right? So let's write this as the multiplication problem. This is 3y over 4, because the first fraction always stays the same, times 1 over 5y cubed. Is that all right? So at this point, guys, 3 and y will just kind of separate like that. 3 times y, and then times 1. And then what does 4 separate as? 2 and 2. 5 is prime, so he'll stay at 5. And then how do we separate the y's? Y times y times y. Because y cubed means 3 y's there. All right, the numbers don't reduce at all. The 3 and the 1 don't reduce with anything on the bottom. All we can do is knock out 1 y, okay? So we'll do the y here and the y there. After you cancel what you can, you just multiply straight across the top. So 3 times 1 is just 3. And then on the bottom, what do we have? 2 times 2 is 4, times 5 is 20. What do these two y's change to? Y squared, you got it. So y times y gives you y squared. So 3 over 20y squared. Does that look good? All right, last page, you guys are doing awesome. So now they're going to say, oh, good job, guys. You know how to do multiplication division. So let's just do all kinds of order of operations and so forth, all right? So order of operations, what do you have to do first? Parentheses, okay? So this is step number 1. We're going to get that down to a simplified fraction, okay? And then we're going to divide in step number 2, okay? So let's rewrite this as negative and a big fraction, okay? And then this divided by 7 over 15 is just going to hang out, all right? I'm just going to focus on my parentheses, and I'm going to multiply like normal. What's a negative times a positive? Negative, so that's why I have a negative hanging out. And then I'm just going to focus on the inside fractions, okay? So how does 2 break up? Just a 2. But how does 9 break up? 3 and 3. How does a 3 break up? He just stays a 3. But how does a 14 break up? 2 and 7. Is that okay so far? So the 2 will knock out the 2, and the 3 will knock out a 3. So this is really equal to, and I can get rid of my fraction or my parentheses now. What, negative 3 over 7? Do you guys agree with that? But who do I still have tagging behind it? Divide by 7/15, which is really the same thing as multiplying by what? 15 over 7. Does that look right? Did I do something wrong? Does that look good so far? Okay. So then at this point, everything is going to be what? What's our final answer going to be?
45 over.
Yeah, and what's our sign going to be? Look at you guys, we're already doing the math. Okay. Do you guys agree that we don't really need to do this part? You can, but 15 split into 3 and 5 doesn't help us because what's the only thing we have on the bottom? 7s, right? So at this point, we can just go straight across like you guys did. Negative 45 over 49. Is that what you got, Scott? All right. The last two, well, I guess almost the last two, example 16 and 17, are just making sure we can evaluate and check if they're the right solution and so forth. So basically, we're just plugging things in, okay? So part A wants to make sure we can do multiplication, x times y, okay? So what is x? Negative 3/4 times y, 9/2. But right below it, guys, I'm going to do my work. What's a negative times a positive? Negative. What's 3 break down to? A 3. What's my 9 break down to? 3 times 3. On the bottom, what's my 4 break down to? 2 and 2. And then what's this guy break down to? 2. So again, I kind of feel like I've done it all in vain because once I break them up, all the 3's are on top and all the 2's are on the bottom, so nothing cancels out. But like I said, the second I don't do that, something's probably going to cancel out, okay? So since they don't cancel out, guys, we're just going to multiply straight across. So the answer is going to be negative. 3 times 3 is 9. 9 times 3 is 27. 2 times 2 is 4. 4 times 2 is 8. So we have negative 27/8 for part A. Is that okay? Nothing canceled, so you didn't really even need to do this part. Part B is x divided by y, which is negative 3/4 divided by 9/2. But do we ever really do division? No. So how can I rewrite this? This is negative 3/4 times what? 2, 9. So this is really the problem I'm going to do. So I'm going to leave my workspace down here. A negative times a positive is a negative. I'm going to write one big fraction. My 3 and my 2 up top don't break down any, so they'll just be a 3 and a 2 up top. My 4 on the bottom will just be a 2 and a 2. And my 9 on the bottom will just be a 3 and a 3. Is that okay, guys? So initially I wrote it with the real direction, right? My x, negative 3/4 divided by my y, 9/2. So I wrote it as the real problem first, but then said we never really do division, so I need to change my division to multiplication and flip it. And at that point, 1, 3 and 1, 2 will disappear. What do I need up top to show that the stuff that remains is in the bottom? Negative 1, perfect. And on the bottom you have 2 times 3 or 6. So notice the difference between our two answers. The exact same x, the exact same y, but when you multiply and divide, you get two different answers, which you should, right? 2 times 3 is 6, but 3 divided by 2 is not 6. All right, second to last one. You guys are doing great here. We just want to make sure negative 9/8 is the solution for this. Remember, that just means plug it in for x, and then if you do the math here and it equals that, it is a solution. So we're going to have 2 times negative 9/8, and we want to know what that is. Well, I'm going to make that 2/1. So what's a positive times a negative? A negative. How does 2 split up, guys? Just a 2. How does my 9 split up? 3 and 3. My 1 will be the 1, and then we've done 8 1,000 times. 8 is how many 2's? 3. Okay? So I'm just kind of doing what we did before. My 2 is my first numerator. My 9 is my second. 3 times 3. 1's my first denominator. My 8, 2, 2, 2. Okay? At that point, 1, 2 will cancel out. Is that it? So up top, you have a negative 3 times 3, or a negative 9. On the bottom, you have 1 times 2 is 2 times negative 9/4. So what do we say about it being a solution? Yes. All right, for those that act like you're not good with fractions, you guys are doing pretty well. Are you feeling a little bit better? Yay, nay, okay.
This is much easier than what I learned in high school.
Did I just need to be your high school teacher?
I know, right?
Right? Just tell me. We'll get it on record, right? Not too bad. They're not that scary, right? Okay. Let's do the last little thing here. I want to point out one key word so you know it's either multiplication or division. All right, let's look at what it says. It says Hershey Park is an amusement park in Hershey, Pennsylvania. Of its 66 rides, 1/6 of these are roller coasters. So how many roller coasters are there in Hershey Parks? Of means multiply. So we're going to find 1/6 of the 66 rides.